is no question that our climate is changing, and how it will affect life on this planet is of great interest. Will we be able to adapt? Glaciers, which have formed over tens of thousands of years, can give us important information into our climate and how it has changed over time. And what is scary is our glaciers are melting at an alarming rate. To learn more, we came here to Mount Elbrus to speak to Viktor Popovnin. He is a glaciologist who has devoted his entire life to the topic. It is a fascinating, at times dangerous, and very important job.
Glaciers are natural indicators of climate change. It's becoming warmer. Someday they will disappear. Today, we're seeing the same trend in almost every mountain system. Glaciers are shrinking. They're getting smaller.
Do we need to worry about ancient viruses coming into our system?
It's definitely something to consider.
Is there anything we can do as humans, or are we helpless in this process?
The only way to slow down the melting of glaciers is through a massive intervention. A nuclear war scenario. All the glaciers in the world would stop melting. Being able to do my job and do something useful for humanity, so I hope, is my prime motivation.
Victor? Good to have you out here. Thanks for having us in your office, as it were. It's hard to believe that these glaciers will disappear someday. How much time do we actually have?
Someday they will disappear, but they'll be here for our generation, the next few generations. The glaciers here in the Caucasus follow certain cycles. One cycle lasts about 1,800 years. In the 1st century BC, the glaciers were at their peak. Then they began to shrink and almost disappeared around the 5th century AD. We refer to the period between that time and the 10th century as the Archean break in glaciation. Research near Archean showed that the peoples of the North Caucasus freely moved south because there was no ice on the mountain passes. You could easily cross to the other side. This cycle will repeat, and we can extrapolate from the data we have to predict the next period. The last peak, the so-called Minor Ice Age, was between the 17th and 19th centuries. Add about 600 years to that. In about 4 centuries, there won't be any glaciers in the Caucasus, unfortunately. Just a few isolated spots will remain. Of course, the ice won't disappear from the Caucasus altogether. There will be some places where glaciers remain, but there will be very few of them.
So you've been studying one particular glacier, Jankuat, for your career, for decades now. How has that changed over time?
Scientists have been closely studying the Jankuat Glacier since 1968, for over 50 years already. It's somewhat typical, average size and altitude. This glacier is in a valley. You can see it all the way back there. It's sitting in a saddle between 2 summits. Moscow State University has been in charge of researching it. By studying this glacier, we can see patterns that are relevant for all ice in this area, and even the whole Caucasus region. The research shows that the glaciers are receding, becoming smaller in size, volume, and height. They're thinning out. In the 1960s, the glacier covered 3.2 square kilometers. Now it's 2.5. So it's lost about 20 to 25% in 50 years.
So as glaciers recede, or as they change over time, the weather can change as well. Have you seen any changes in the weather or any consequences of glaciers receding here in this specific area?
Over the last 50 years that the glacier has been monitored, the general trend has been towards a gradual increase in precipitation levels. And it's a good thing for the glacier. Accumulation of ice in the glacier depends on the total amount of precipitation. You see, my heart bleeds for glaciers, because I study them and would like them to exist for as long as possible. But unfortunately, this trend cannot offset the opposing tendency related to the summer period, when glaciers lose mass. That's the result of changes in solar radiation levels and air temperature. Glaciers are natural indicators of climate change, and changes in climate determine how glaciers behave. Air temperatures are rising everywhere across the globe, which is a strong and steady trend. It's becoming warmer. As a result, the glacier is losing mass at an increasingly rapid rate. The balance between these two processes, accumulation and ablation, is tipping towards a loss of mass. So the glaciers are presently losing mass, and the trends of the summer season are prevailing, for now at least, over the modest, even if positive, trends of the winter season.
Understand. Now, it is said that a glacier can be kind of like a time machine from the moment it was formed until today. Can you read glaciers like a book? What kind of information can you get from them, and how do you actually extract that information?
The monitoring activities at the glaciers today include mostly direct observation. We take direct measurements. It could be snow gauging surveys or measuring the snow melt level using a variety of tools like rods. Then we verify the obtained results by comparing them to geodetic measurements, geophysical survey data, etc. However, this only concerns present-day monitoring, where we make observations as we work. Information about the time before we came here can only be extracted from the depths of the glacier, and you need to pull out an ice core by drilling. The glacier, throughout its thickness, is a kind of data repository where information is stored about events in the distant past. The history that can be retrieved from the glacier does not go back endlessly, though. The glacial mass renews. Here in the valley glaciers of the Caucasus, we won't find ice dating back dozens of thousands of years. The Juan-Quat Glacier, for example. The full cycle of ice mass exchange completes every 110 years. In some other places, older ice can be found in subglacial cavities where it stays intact longer. But with glaciers like this one, we can only get information about climate change over the past 100 to 110 years if we extract an ice core. Exactly what information can we get from an ice core? If we can discern annual layers in the sample, they'll show us the mass balance in the glacier each year. And we can identify the exact year by isotopes and other techniques. If we drill a well at a spot where complete meltdown of ice never occurs, we can count how many layers we have and date the layer we're interested in. Then we get the value of mass balance for that particular year in that particular spot, which is composed of two scientific methods, including radioisotope dating science, to distinguish between these parameters. We can see how the temperatures and precipitation levels changed throughout these 100 to 110 years. We can also evaluate the changes in the chemical composition of the atmosphere over a certain period of time, if we analyze the impurities, aerosols, etc., captured in the ice. And then a plethora of analytic methods can be used to evaluate the environmental situation and climatic parameters at a given time in the past. That's how it all works.
So I have to ask, a lot of people think of science as just paperwork and numbers, but your job can be dangerous. There's long expeditions, there's cracks in the ice, there's bad weather, avalanches, let's say. What's the most dangerous situation that you've ever encountered? Have you ever been scared for your life? Talk to me a little bit about that aspect.
Mountains have always spelled danger for humans. They're not safe. When we're working on a glacier, we have to think about the safety of the procedures we're carrying out first of all. No scientific result is worth a lost human life. However, we can anticipate and avert any danger. It's one of the main tasks that explorers of the mountains pursue, to identify the potential dangers and take measures to increase their safety as best they can, broadly speaking. We have to walk across crevased surfaces and icefall areas when working on the glacier, which requires proper mountaineering gear and techniques, including safety equipment like a harness. That's what we teach our students and what we use at all times. However, certain events can't be anticipated. Avalanches, for example. That's why every time we get onto a slope, we have to assess the avalanche hazard of that particular location first. There are slopes which are strictly prohibited to access in any weather condition. no matter how convenient they might be for completing a scientific mission. And ideally, we have to keep that in mind from the start and try not to plan any measurements on avalanche-prone slopes. We can't position our equipment there because we need to be able to access it at any time. Unfortunately, you can't do this everywhere in the mountains. You have to pick locations carefully. Falling rocks are another danger. Rock slides are a frequent occurrence in the mountains.
In 2009, Viktor's glacier monitoring base was destroyed by an avalanche. Fortunately, nobody was hurt, but descending ice and snow is a major threat to everyday life here. The region is one of the most avalanche-prone places in the world. Rising temperatures are cause for the changing face of the terrain. Igor Komarov has been battling snow collapses here for over 30 years. He's on the military avalanche control squad. He knows these mountains better than anyone. Igor, thank you very much for coming out to meet us. I have to say that when we were coming down the mountain to actually meet you, Viktor and I witnessed an actual avalanche. So I have to ask, are avalanches happening more often?
The frequency of avalanches has to do with climate change, but it's the type of change that's not directly related to global warming. Still, I have to admit, we're seeing more avalanche activity nowadays. For example, there was a massive pine forest near the village of Terskol. That's further over there. But now it's just birch trees. Before 1969, there were pine trees everywhere, but they've gone now. Avalanches have wiped them out over the past 50 years.
So have you ever personally witnessed an avalanche? And if so, tell me about that aspect. And that was not a controlled situation. And how did you handle that?
Yes, I have seen avalanches. In fact, I was caught in one. On March the 8th, 1973, in the Donbai region, that's in the Western Caucasus, I was with a crew filming a science documentary. On our way down the mountain range, a massive snow slab came crashing down. Luckily, I was just tossed aside. Spontaneous avalanches like this happen from time to time, primarily in places that have no avalanche control.
What time of year do avalanches most happen, or when do they frequent this area? Should I be worried about an avalanche right now?
Even for a layman, there are certain meteorological factors you can track to determine whether it's safe or whether it's time to pack up and head down. First of all, we're talking about heavy snowfall. The longer it lasts, the more dangerous it becomes. Secondly, it's what we call wind transport, when strong winds carry huge amounts of snow from one place to another. Even to a beginner, these two factors are very important to take into account. Beyond that, there are warning systems in place. In any case, you should always rely on your own observations. Right now, of course, it's still very early for avalanches that could threaten the valley, so you're perfectly safe.
So I know that they send off cannon charges, and there are different ways that you can control an avalanche. You're the expert. Your experience is unparalleled because this area is known for avalanches. What is the best way to control the situation?
The United States, Russia, and Canada were the first and probably the only countries to implement state-run avalanche protection systems. By the way, Europe has no such system. In our many years of experience, we've learned that the best approach is a combination of different measures. First off, various avalanche defense structures, like the avalanche gallery and the snow retention structures we passed on our way here. These are combined with a number of active measures. But like I said, the important thing is to combine anti-avalanche structures with active interventions, such as shelling and other preventative efforts.
So as glaciers get smaller, they reflect less sunlight out into the space, which makes the greenhouse effect on Earth increase, which makes glaciers melt. Are they killing themselves in this case?
Any glacier, whether it's shrinking or growing, reflects more sunlight than the surrounding bedrock. The main point here is that the glacier creates a local climate which is cooler. Above the glacier, the temperature is typically lower compared to the surrounding mountain area. That's one of the effects of these glaciers.
Is there anything that we can do to maybe slow down the process of glaciers melting and glaciers receding? Is there anything we can do as humans, or are we helpless in this process?
The shrinking of glaciers due to global warming is not so much a product of human activity, but rather a consequence of certain external factors. The only way to slow down the melting of glaciers is through a massive intervention. For example, we could cover an entire glacier with a layer of rocks. There are other, more unconventional methods. For example, although it may sound depressing, the nuclear war scenario. Scientists have come up with different simulations of how glaciers would react in the case of a hypothetical nuclear conflict. I personally hope it remains a hypothesis. So if we are talking about 4,000 to 5,000 megatons, the explosions would release vast quantities of soot aerosols into the atmosphere. This would reduce our atmosphere's transparency to such an extent that the global temperature on Earth would drop to minus 20 degrees Celsius, or according to some predictions, down to minus 50 degrees Celsius. As a result, all the glaciers in the world would stop melting. While this is an effective way to slow down the melting, I hope this scenario remains purely hypothetical.
So, if I understand also correctly, in the 10th century, here in this region, the glaciers drastically receded. And then there was the Little Ice Age.
This is just one of the cycles, and there have been multiple cycles like this over the millennia. Normally, these cycles do not follow the classical sine wave pattern. Glaciers increase in size quite rapidly, but it takes a very long time for them to shrink and disappear completely, as was the case during the Archean break in glaciation from the 5th to the 10th centuries.
So one question I have is this all connected in one giant ecosystem globally? Do the change of glaciers here have an effect elsewhere in the globe, somewhere, let's say, in Kenya?
I don't think so. The same effects are being observed across the globe due to climatic reasons of a global nature, a cosmic nature, if you will. Today, we're seeing the same trend in almost every mountain system. Glaciers are shrinking. They're getting smaller. But it's not a permanent process, and it's not uniform across different ecosystems. It's true, glaciers are shrinking fast across most of the globe. Right now, it's particularly evident in the Rocky Mountains, North America, in the Alps, or the Kodar Mountains in the Zabaikalsky territory in Russia. Yet at the same time, there are mountain ranges where glaciers are doing quite well. Many glaciers in North Scandinavia are increasing their mass and even advancing. Scandinavia is in a better place in this regard than many other regions. Until recently, the late 1990s, the same positive trend was observed in a number of other mountain ranges. For example, around the Greenland Shield, in New Zealand, even in the Caucasus. In the late 1980s, early 1990s, there was a period when glaciers were doing much better than now. They even stopped receding, while some were increasing in mass.
So, also my understanding is that as more glaciers melt, it adds fresh water to the oceans. And that can slow down the Gulf Stream, which can cause temperatures to drop in Europe. How fast can we expect that to start happening? Or is it already happening?
To a certain extent, it happens all the time. The more glaciers melt, the more meltwater is released. But this isn't as simple as that. Apart from releasing more water because of increased melting, ablation, glaciers are also shrinking, so their area is getting smaller. And the product of a great runoff multiplied by a smaller area doesn't result in more water. After a while, glacial runoff will start decreasing, and it's happening already. Yes, glaciers seem to be responding to climate warming and are melting more. But it doesn't mean that the volume of fresh water will continue to increase forever.
Now, something that you touched on earlier in our private conversations, is about the idea of fresh water for populations, is that as glaciers recede, there will be less fresh water for civilians. Talk to me a little bit about that.
This is the key thing to remember when we plan glacial monitoring. Essentially, glaciology, the scientific study of glaciers, has two practical goals. First, to learn about how water resources are changing. Water is humankind's main natural resource. Second, to protect us from disasters. As for fresh water resources, it's true that it's been a major concern in some countries for a while. But different countries have different approaches to it. In the arid areas of Central Asia, shrinking glaciers mean less runoff, which could lead to catastrophic consequences in the future. It's beginning to be felt even today. Their reservoirs are getting less water than what they were originally expected to hold. Last year, Kyrgyzstan faced the issue of insufficient water for hydroelectric power plants. They even started preparing people for the idea that there might be rolling outages due to low water levels in the reservoirs. This problem is only going to get worse, and I think we'll see more frequent instances of that as glaciers melt.
Well, you mentioned about more frequent catastrophes. We've seen in the movies, we know that the seawater is going to rise and that the coastal cities could be obliterated by floods. Where does science fiction and reality meet? Like, what can we really expect, or do we not even know yet?
64 meters is the classic threshold by which the sea level is expected to rise in theory. That won't happen. Ice on Earth, at least at this stage of the planetary evolution, is never going to be completely lost. I'm talking about the ice mass in Greenland, Antarctica, etc. Essentially, what we're saying about the evolution of the ice cover mostly has to do with mountain ice. But all mountain systems of the world combined only amount to about 3% of the total ice reserves. Most of it's in Antarctica. For this mass of ice to melt, we'd need a planetary cataclysm, what I would call a cosmic level event, like an asteroid crashing into our planet.
All right, staying on the idea of where fantasy meets reality. We know that in Antarctica, they've discovered viruses deep in ice, and we know that in China recently, the same thing has happened. Is that something that we need to worry about? We're coming off of a pandemic here. Do we need to worry about ancient viruses coming into our system?
I think this is something that needs to be looked into. The idea that there may be ancient microorganisms which could be released after ice melts makes sense, but it's not a concern for the whole world to lose sleep over. Although doctors, ecologists, and other relevant specialists should be the ones to judge, it's definitely something to consider.
Now, we've talked a little bit about this privately as well. Your job can be dangerous, but it is really interesting. It's really cool. What keeps you motivated? What about your job is fascinating to you?
For me personally, each researcher has his own reasons. For me, mountains are the most aesthetically pleasing part of the world's surface. What's interesting about mountains is that neighboring valleys can have entirely different landscapes, offer different views. When you're on a plane, you need to go to other regions or other countries for a change of scene. Here, things change very quickly. Mountains are so diverse. There are so-called modern-looking alpine-type mountains like the Caucasus or the Alps themselves. There are older, smoother ranges, which can still be very high, like the Tian Shan. There are these needle-like mountains which look like something from a moonscape in Patagonia, Argentina, my favorite region. Very beautiful mountains, unforgettable. For me, working in the mountains is a joy. Being able to do my job and do something useful for humanity, so I hope, is my prime motivation. Global models, countries that need to manage their water resources for the purposes of hydraulic engineering, or simply economic activity as a whole needs data from different mountain systems. What we're doing here in the Caucasus, for example, is really important for international databases. There is a certain political dimension to the study of glaciers. For example, right now we're working on a glacier, part of which is in a foreign country, Georgia. We used to be able to take measurements across the entire glacier. You need to cover 100% of the area to determine the mass balance. It's more difficult now because, alas, there is a border. I don't like to discuss politics, but it's something you have to take into account. because political developments are increasingly impacting on glaciers. Take water use in Central Asia. There are serious conflicts emerging between neighboring countries like Kyrgyzstan and Tajikistan. Chile and Argentina are another example. They had major differences on where to draw the border. I believe all of this requires glaciological knowledge to resolve. I'd like people to know more about glaciers.
Viktor, thank you very much for showing me around your office. It has been a true pleasure. Hope to come back and spend some time with you here again sometime.
Thank you.